Hello, so welcome to this lesson about the p-value. So in fact the p-value is another methodology to check our hypothesis. Previously we have seen using the test statistic, which is Z0. Also we have seen the use of confidence intervals to check and examine our hypothesis. Now we are also going to use another methodology, which is the p-value, to make decisions and conclusions about our hypothesis. So what is the p-value? So here in the graph we have seen the normal standard distribution, standard normal distribution with acceptance region in the middle, for example 95%, which is the confidence level. We have alpha to be 5% in case of two-sided test, or in case of two-sided hypothesis we have 2.5% to the right and 2.5% to the left. So what is the p-value? Formally we have the definition of p-value as the minimum value of alpha. Sometimes we call this as confidence level or the error. So the minimum value of alpha which will lead to reject H0 is the p-value. But informally, and to make this more clear, the p-value is a methodology or a value to represent how close that the sample mean is to the population mean, or how likely that statistic, for example, did not belong to the standard normal distribution. In our case, we are here examining the mean value. So now we are going to see more clearly how to compute the p-value and how to use the p-value in testing our hypothesis. Suppose this example, we have previously seen this example about the capacity of water bottles. We have Z0 in something like minus 0.435. we have the absolute value of Z0 to be 0.435. So what is the p-value? In case of two-sided test, we have here two-sided test. So the p-value in fact will be the area under the curve to the right of absolute value of Z0 and also to the left of Z0. So suppose we are going to use the cumulative distribution function of the normal distribution. We are measuring the p-value as 2 multiplied by 1 minus phi of absolute value of Z0. So let's look what does this equation mean. The absolute value of Z0 ensure that we are in the positive side. So we are here greater than 0. So suppose here we are the absolute value of Z0, this brown line. So the cumulative, in fact, the cumulative distribution function gives us the area under the curve from minus infinity to the point. So phi of absolute value of Z0 will give us the area from minus infinity until Z0, until this line. So if we have 1 minus this area, so this will be the area to the right of the brown line. The area to the right of the brown line is 1 minus phi of absolute value of Z0. If we multiply by 2, we will have the area to the right of this brown line plus the area to the left of this brown line, because as we know the normal distribution or the standard normal distribution is symmetric around the 0. So the right side is exactly the same as the left side. So we have an even distribution or symmetric around the mean value, which is 0. So in fact, what is p-value in this equation? In the case of two-sided test, the p-value is the area under the curve to the right of this brown line, which is absolute value of Z0, plus or sum to the area under the curve to the left of Z0, which is from this brown line to until minus infinity. So what will we have? By computation or from the tables of normal distribution, we have this value, and we have so calculate the p-value to be 0.664. So what we are going to do, we will use the p-value to examine our hypothesis. So the rule says that we will only reject H0 if the p-value is less than alpha. So if the p-value is less than alpha, we are going to reject the null hypothesis or H0. But in our case, we have alpha only 5%. We have alpha only 0.05. So what are we going to do is that we have failed to reject H0. So we have failed to reject H0 at confidence at alpha 0.05 because the p-value is much larger than the value of alpha, which is clear from the graph. In fact, alpha is this blue area, this one and this one, to the right here and to the left here, but the p-value is the area to the right of the brown line here, also to the brown line here. So it is clear that the p-value include or represent a larger area than alpha. So if the p-value is larger than alpha, we fail to reject H0. So again, this is the normal distribution or the standard normal distribution. In the middle, we have the acceptance region. In both sides, in case of two-sided test, we have the rejection area. This is alpha over 2, and this one is alpha over 2. And in between, we have 1 minus alpha. So now what happens if Z0 is very close to 0.0? So the more Z0 will go to 0.0, the more value we will have for the p-value, because we will have larger area covered by Z0. This is in fact due to that the sample mean or x bar is going more close to the hypothesized mu. We know from the equation that Z0 equals the difference between the sample mean and hypothesized mean for population divided by the standard deviation of the statistic, which is x bar. So what will happen if the sample mean exactly equals the population hypothesized mean? So if x bar equals mu, this will lead to Z0 be 0.0, and in fact if Z0 is 0.0, we will have the area to the right to be 0.5, area to the left will be 0.5. So the p-value will be 2 multiplied by 0.5, which is 1 or 100%. So this means we will have the larger possible p-value to be 1, because we have the sample mean exactly the same as hypothesized population. So this makes it more clear that the p-value measure how likely x bar is more close or represent the hypothesized mean. So the more that x bar is close to mu, we will have larger p value, and mostly we will fail to reject the null, and we will say that the null hypothesis is still valid and the mean value of our population has not changed to other values. As we have seen, we will only reject the null in case of the p-value is less than alpha. This is our conclusion. So in our case, we will fail to reject the null hypothesis.